Hi, this is part 2 of a video series regarding testing direct transfer trip over XTran using a DTT module from Schweitzer. So here's 2 DTT modules. I invite you to look at the previous video, and there's a description of this back-to-back. And right now, this time around, what we have is we got DTTs going over C3794 right here over the XTran network. So because this is packet based, I've had disturbance traffic. In a TDM world, I think just testing one application would be sufficient, but in a packet environment, I think it's important to have 100% or near 100% load to make sure that the system's working fine. So we got these 2 nodes right here. Here's an Ethernet test generator, as well as a T1 tester, and this has been running overnight. So as we can see here, we're up to 56,000. The left counter is the DTT input that come from a generator, and we have 56,000 or so trip inputs, and if you look at the output, it matches 100%, so no trips whatsoever have been missing. Now, if you remember, this back-to-back application was within 5 milliseconds. So let's take a look at the additional delay that XTran brings in. Let's increase the frequency of the trips just so that we can see all the variation. So as you can see right now, the top again is the DTT input, and the bottom is the output contact. And as we can see, it's below 6.2 milliseconds. So XTran is only adding 1.2 millisecond to this of delay of latency to this application. So 1.2 millisecond additional delay because of the XTran network. Of course, this could increase because of fiber. Here we only have like a meter of fiber or so. Now let's take a look at the traffic that I showed you here. So what we are showing here is basically the Ethernet. So the link is loaded 100%, as you can see right here. The capacity, it says 100%, but that's it's probably a little below. The capacity of this link was 974 megabit, and we're loading it up to 971. That's as close as I could get it to 100%. You cannot exceed it, and XTran on MPLS-TP does not allow oversubscription. So we have the Ethernet traffic. We are showing here the T1 traffic, and here's the DTT right now, and that's the transfer trip, which represents a lot less bandwidth than everything else. So if I look at the performance right now live, what I'm seeing is that I'm looking here at the line side, the MPLS port going out of the XTran node number 1, and it's loaded 100%, while the other fiber here does not carry any traffic, is there for protection. So I just want to make sure, showing you this, that essentially all the traffic is going over the same fiber, and it's not shared between the redundant links. So what are we? Let's look at the traffic generator, see if it lost any frames overnight. Here it is, and as you can see, there is no duplicates, no gaps, and it's transmitting 890 megabits per second and receiving 890 megabits per second. And the delay for this application is very short. It's 72 microsecond. There is no no packetization. This is not TDM. The T1 has also been running overnight, and as you can see right here, it's been running error-free all night long. So I think this is a very good test in terms of making sure that none of the traffic is 100% error-free. So the next step on the next video, what I'm going to try to do is show you what happens when we perform some fiber cuts. So of course, when we do some fiber cuts, there is a reconvergence. Traffic is lost for a while, and then it comes back, and we'll see how it affects DTT. A lot of people say that we shouldn't worry too much about that. In fact, that's not the case. If you usually, if you have a storm or something like that, you will experience, if your transmission line gets hit by a tree or something like that, you'll lose your fiber at the same time as there is a fault on the transmission line. So these things do occur simultaneously, and we want to see how it behaves under different fiber cut scenarios. So that's going to be the next video. All right, thanks for watching.